Okay, so real-time asset pack. And today we will discuss memory usage. But of course, Task Manager is not a good representative of that. But as you can see, this thing is quite lightweight because entirely Unreal takes just 1752 megabytes. But there are two types of memory, of course, the RAM and the GPU memory. Here in the Task Manager of Windows 10, you can see it under dedicated GPU memory usage. Of course, it's the total thing for the entire desktop, right? Right now it's at 3.5 gig out of 8. Of course, GPU memory is much more valuable these days. It's also more costly because it's GDDR6 or 5. Okay, so we have our scene. This scene looks quite rich in detail. There is nothing lacking in that regard. A very good quality. Okay. But in general, as you can see, there is not so many assets that are unique. Of course, this is not Nanite. This is converted from Unreal Engine 4. So if you go to, I think it's not, go to triangles, there's nothing there in Nanite. So it's standard meshes looking like this. And as you can already see, the interior is very optimal. There's just two big triangles for that wall and so on. Just a couple for the floor. Hey Bionic State, thanks for subscribing, for following. Okay, so this scene looks lightweight, but is it? What can you check? First, check your scalability settings. Usually, there is no point in having these things at Epic, but Epic is the default. So just click high and consider that a standard thing. Resolution scale could be at 100% actually. So that's one thing to change. Okay. And now the memory. What can take our memory? These are meshes, of course, mesh data, textures, right? Physics data also, though usually it's not that much. And in terms of the entire rendering, these are also the full screen buffers and various kinds of volumetric stuff, particles, right? But not only volumetric fog and stuff. So for example here, let's assume that this is full HD. It's almost full HD. So we have this final rendering buffer. It has to be in some resolution, some texture format. So you can imagine that the final thing is probably something like RGB 8-bit per pixel, maybe more if we're rendering HDR. But there are more. If you go to buffer visualization, you can see, for example, roughness, of course, but this is just one channel. You have base color, you have metalness, normal. Where is it? Where is it? Yeah, here. And all of this together is called the G buffer. So G buffer are the full screen buffers of every all kinds of material parameters that are later used together with lighting to produce the final image, the one in the middle. But all of these, of course, take your memory. You can't just keep memory for the final thing, right? You have to reserve it for everything. So this is only influenced by the resolution, not just the resolution itself, not only the resolution of presentation, but as you know, there's also the resolution scale. I just lowered it. It doesn't look that bad because Unreal has something like temporal resolution scaling, TRS. Anyway, the thing is that you render the image in the lower resolution, like in NVIDIA's DLSS, and then upscale it but in an, let's say, intelligent manner. Let me disable that again. 100. I don't know the way to show it, to be honest, but imagine that your image is rendered in lower resolution, but then using data like this word normal thing, like this thing, you know where the edges are, so you can make them sharper. You know that this edge should be treated differently. So in the end, lower resolution image is not just simply upscaled with some Gaussian kernel or some bicubic, but in a much more advanced way. So rendering at lower resolution at least reduces the weight of the gbuffer. So only the final image stays the same. Hi Sadokun. But in general, that's the only thing that you can do to influence it. In Unreal, you can't change that much when it comes to the layout of the gbuffer. It's predefined for you. Another thing that may take your memory, aside from meshes, textures, and gbuffer and volumetrics, are all kinds of additional maps like lumen. So lumen is here. Lumen scene, okay. This isn't using lumen, so we don't care that much. But also lumen and also reflection probes. Let me find some reflection probes. G, right? Yeah. Sphere reflection capture. So the thing like that has some distance over which it works. And of course, reflection captures have predefined resolution in Unreal Engine of 128 pixels per edge. They are cube maps, so you can imagine that, okay, it's a sphere, or maybe they're rendered differently, I don't know, but if this was a box capture, it would have this, then, you know, like that, and each edge would be 128 pixels. And this is heavier than typical 128 textures because they are HDR, meaning they can be brighter than 1. Because of course they have to capture the environment, not just the final white, but also imagine something like that despite, you know, white, it's not clipped to white as it would be. You have to retain more information. So HDR textures are more expensive, and they are used in our reflection probes. Okay, if you have light maps baked, here we probably do, I don't know how to check it. Yeah. So light maps, of course, also take some memory. So take that into consideration. Don't just think, oh, you can see they're quite low resolution here. Don't just think it in terms of the material texturing, but also stuff like light maps, which are textures too, right? And as for their density, you go here and there was some light map density. Oh yeah, optimization view modes, light map density, red, but uniform. Okay, here you have mesh UV density, but it doesn't matter much because we very rarely use actual default UVs from the mesh, right? We rather do tiling and stuff like that. So here you can see a texture of these tiles repeated many times. So yeah, it's not a good way to check. To change the resolution of captures, there are only two modes, 128 pixels or 256. You go to editor preferences, reflection. Wait, capture? Not editor preferences, project settings, of course. Okay, And here you can see reflection capture resolution. Oh, sorry then. It seems that in Unreal Engine 5 the default is 256. But yeah, here is where you can change that. Okay. So now, what can we do to check the texture memory usage? You go to Tools on the top. You go to, where was it? Audit, and then Asset Audit. No, Statistics. Sorry, Statistics. You click that, and now remember an important thing. It may happen that if you're dynamically loading a level, and let's say there's nothing by default, you will need to actually play the scene in the viewport to have that. So these statistics, they reflect what you see there. So you can just click here, select the viewport, play. Okay, now we play, now we're in the game. Now you go back to your statistics window and you do refresh. Okay, it's refreshed. It tells us the name of the texture, actors using it. Is it 2D? Is it virtual texture or not? Maximum dimensions and current dimensions. This is important because you can import the texture in a bigger size and then optimize it for a given platform. For example, lower resolution on Xbox or something. The group. And here you have the fully loaded memory size and currently loaded memory size. So again, this currently loaded is related to this current dimensions. Okay, so let's say we sort by fully loaded. And again, okay, so the plants texture is the biggest one. And here we have uses. So this plants R is used 11 times in 11 actors. If you click on these actors, nothing happens. Okay, if you click on these actors, they are becoming highlighted in the outliner. Okay, I will exit this game. Where are they actually? Okay, they are there. Here. Right? So as you can see, these little plants use the heaviest texture in the map. 43,000 kilobytes, 43 megabytes. You click on it, it's highlighted again in the asset browser. We open the stuff, and here you can see it, that this little succulent is using that texture, which is, in the time we run the game, it's actually streamed in as 4K. Why is it streamed as 4K? Why it's so small? Shouldn't Unreal stream by Mipmap? Of course it will. The problem is that somebody disabled streaming for the texture. So you can go, where is it? Not advanced, this advanced probably. Where was it? Stream. Oh, never stream is disabled? Okay. Anyway, it says not streamed. 13 Mipmaps. So we can go to lower levels also. Richard Mao, welcome. Richard says, so nice to finally catch your stream. Been watching your YouTube videos. Cool, thank you. So, I don't know, chat. Let me know if you have ideas why this one is not streamed. It should be, because typically not streamed happens when the resolution is not a power of 2. But here it is. Okay, power of 2 is none, but we can pad to power of 2. Still not streamed, so I don't know. Anyway, maybe that's some setting in the project or in the platform. Give me a moment. Device profiles or manager profiles. Okay, Windows. Cool. Texture LOD settings, Word. Simple average. Okay. Oh, and here you can see this thing that for a given platform, I click this 3 dots, platform editor opens, you go to texture LOD settings, and you can say LOD bias. I will show it in a moment. But there's nothing about streaming here, so I don't know what happened, to be honest. Console variables, rendering, nothing. Okay, whatever. Bionic state that maybe is in the material. Sedokun, as for the never stream, it's disabled. So I don't know. Anyway, it's not streamed, it's 4K. And as you can see, this extremely detailed texture was used for this tiny succulent here. Okay. And we know that it was used for them because when I move them, these are the only ones selected. So what can we do? We found already, this is the heaviest texture, 43 megabytes. So we open it once again. We zoom onto the plant at the maximum possible zoom. Let's say this is the max, right? Open this. And in the settings, there is LOD bias. LOD bias in that case means bias in the Mipmap used. So Mipmaps, as I said, are the lower resolution versions of the texture. Mipmap 11 looks like, okay, Mipmap 9 looks like this. MIP 8, MIP 7, and of course MIP 0 is the origin. So bias means that we start, for example, bias of 3 will mean that we start with Mipmap 3 as 0, Mipmap 4 as 1, and so on. So we basically downscale the texture. So let's start with as low as possible. Load bias 13, and look on the left at the plant. Save. Not much of a change. LOD bias 20. Nothing. Wait a second. Nothing's changing. Imported. Okay, max in game is 1 by 1. But why isn't it happening here? Do I have to play the game or something? Ah, because just the roughness. Okay. Sorry. Here is our albedo, also 4K. So let's use LOD bias of 20. Of 0. Almost no difference. Let's find some other view from the top maybe. Or another plant. Again 20. Ah, I have to save. Okay, so 20 is just 1 by 1 pixel. It's too low. Fully blurred. Okay, load bias 12. Bad. Load bias 8. Manageable. Okay, so maybe load bias 10. Okay. 12 again. 11. 10. Ah, 10 is like that. Okay, 9. That's weird. It doesn't look like 9. Let's go 10 again. You know what? Something's wrong. You can clearly see. I'm changing the numbers and getting some bullshit. This is 11. 2 by 1 pixels. It's impossible that 10, meaning 4 by 2 pixels. Yeah, exactly. Okay, 9 again. 10 again. 10. Fuck. Unreal. Yeah, Sudoku says that they recommend using maximum texture size because this is just a shift, but it doesn't prevent Unreal from streaming and the original also will be packed with the project. So let's follow that advice. By the way, something's wrong, as you can see. I changed it to 10, I got nothing changed. Change it to 12, got this. 10 again, blurred, whatever. But let's do what Sudoku says. There is maximum texture size. Okay, here. Also, let's change the clipping plane, because if you go closer, this gets clipped out. So let's do R, set near clip plane to 1 centimeter or to 5 centimeters. Okay, better. Okay, so we have this. Maximum texture size is 0, meaning use the original. Displayed above, so sorry, above meaning here. 4000 by 96 by 248. The resource size is 5.5 megabytes. Let's use maximum texture size of 64 pixels. Not bad. 16 looks like this. So you can see the change. 8 blur. So again, 16 bad, 32 better, 128 fine, and 0 almost identical. So let's stick to 128. Okay. So previously our T-plants R, originally when we have 0, was 5.5 megabyte. With 128 pixels, it just takes 5 kilobyte. And let's keep it like that. And the same with this roughness. LOD bias back to 0, but maximum texture size to 128. Of course it's smaller, but it's good enough. And save it. Plants normal, same thing. Maximum texture size, 128. Okay, back to lit view. It looks okay, it looks fine. So let's look at the rest of the list. There is a vase. Vase was 21 megabytes. Normal of that vase. Where's the vase used? We click on the actors. Okay. Let's move them. Wait. Where's the pivot? What? Where's the pivot? Where are the vases? Yeah, here. Okay. Wait, plants are not vases. What the hell? Or are they? Oh, plants are just called vase, but they're not vases. Oh, here's the vase. Fine. I don't know what Unreal is doing today. It's here. So this material uses vase N, and this little vase, this tiny vase, is here using a texture that's again 4K. 4K. So when there's the point when we lose quality on that, like visibly. Let's go back. The menus got broken. Anyway, here it is. Let's take this normal and again set the maximum texture size. It takes 21 megabytes right now. Let's use 128 pixels. It's bad. It's blurry. 256. Fine. It's a little blurry. But remember, we look at it in that perspective. It's more than enough. So 256, let it stay. Vase N. So let's open other vase textures and set it to the same thing. Okay. Remember to save. This is important. Okay, close it. And let's restart the game. And let's reset this capture. So take a screenshot of what was there before. Yeah, refresh. Cool. So take a look. They totally disappeared from the list of the heaviest textures. So let's sort by name. Let's find our T vase. Here it is. And let's find it previously. Okay. So vase was right there. Vase was right there. And previously, it took 21 megabytes. Currently, it's 85 kilobytes and looks the same. So by using this, you can find out, the suspects when it comes to memory usage. Very useful tool. And now about the meshes. It will be almost identical. So we go to tools. Let me restart Unreal. Save? No. And restart Unreal Engine. Temp. There's this bug sometimes with the menus. Sedokon says, please notice how large RGBA grayscale textures are compared to colored ones. And Biolash, just an interesting question. Do you know how you can check in Blueprint if selected texture has an alpha channel? Could be useful in some review tools. I see. Let's check that later. Because yeah, that could be useful. Okay. We may try to make such a tool. Okay, so now meshes. Tools, audit, statistics. And here we go to static mesh stats. No, primitive stats. Primitive stats. In primitive stats, there are a lot more columns. Some trees, meaning the total number of triangles used by all instances of that actor. However, when it comes to memory, and if you use instance static meshes, you don't have to worry about that. It doesn't matter that much, because there's only one reference of the mesh in memory, and then it being replicated. And even if you don't use instance static mesh, it's only painful, let's say, for rendering, but not for the memory itself. So you just care about size, don't care about sum of all the triangles. So here we have a sign, and this little sign has 900 kilobytes. Let's find it. Actor. You click on this, and it highlights the actor. This is the sign. The Bistrot Dome. Okay. So this little mesh, it takes 900 kilobytes. The rest are okay. Radiator is the next heavy one. So when it comes to the Radiator, here, it's quite dense, okay. However, it has LOD. Let's show LOD, mesh LOD coloration. Right? Wait a second. Doesn't work? Why? What the hell? Never mind. But I think it had LOD. Let me find it. Oh, it doesn't. What the hell? It's just LOD 0. Okay. Let's generate it. Currently it takes 838 kilobytes. It will take more with LOD. But currently we waste triangles because look at this. Optimization view mode, quad overdraw. Okay. What it shows you is a situation that triangles are smaller than pixels. Zaznaczę. Zaznaczę. Okay, maybe now. Yes, no? Yes, okay. Okay, sorry for the trouble. This mic is unusable right now, unfortunately. But I have this, which also has a microphone. Good. I see there's some discussion on the chat. Yeah, if you use, okay, so one thing. Back to the topic of texture. Give me a moment. We have a texture, right? RGB, right? But without alpha, no alpha. So about compression, when you see compression settings here, there are various compression types suitable for different types of content, DXT1 or 5, or BC1 or BC3. What does it mean? Or why, actually? That's because what Sedokun said on the chat, that a texture we can have R, G, B, and A. Okay? However, content on the GPU can be only sent in multiples of 8. So that's the padding. That I don't know the technical details, but imagine you have either some number of bits for this, this, and that, or together. So the typical numbers of bits are 16 bits or 24. So what does it mean for our content? DXT is a method of compression with fixed compression ratio, meaning no matter the content, the optimization is always the same. It just divides the texture into blocks of, I think, 4 by 4 pixels, and it saves color in such a way that it saves the corners and then does a gradient between them. It saves luminance with more precision, but color is treated like that. So no matter the content, you always get the same ratio of optimization. So DXT uses, now pay attention, 5 bits for R, 6 bits for G, 5 bits for B, together giving us 16. Perfect, right? It can't use 6 here and 6 here because it would be an uneven number for the GPU. 16 bits. So if you add A, then currently you have to add up to the next 8. So after 16 we have 24. 24. So it means it has to add 8 bits. So A, alpha, is the channel with the most precision if you use it, but it changes the weight of the texture by plus 50%. So just adding alpha doesn't add you 1/3, it adds you 50%. Also, it means that green is the highest precision channel. So pack your roughness into green because you don't care as much about metalness, which you can pack into R, and about ambient occlusion, which you can pack into B. So G for roughness, alpha for the most detailed stuff because it adds you 50% of the size. Okay, so that's it. be careful. So this doesn't have alpha, so it's the ext1, the best format in terms of lightness, how lightweight it is. Okay, back to this mesh, radiator mesh. It has only LOD0, which is well made, as you can see. But when we move further from it, it becomes green. Why does it become green? That's because these triangles are so small that when we move further, they're becoming subpixel. But the problem is, there's no such thing in rendering a subpixel. You render a triangle, you rasterize it for the given pixel. If it's more than pixel, it just disappears. It can be visible sometimes due to temporal anti-aliasing, because temporal anti-aliasing does something like that, but in a small scale, finding the, let's say, forgotten thin triangles, but still it's bad. So you can see here the bevels, right? We move further away and they just become green. That's because it's so dense that we have an overdraw. Unreal Legend says it's 4 triangles per pixel. 1 pixel, just 1 pixel here, has 4 triangles in them. And there are more and more such pixels when we move away. Because of course, that's how it works. Same here. We have an LOD0 only lamp, which is fine up close. We move further away and things start to overlap. Triangles start to occupy the same pixels, which is way, way worse than it could be. Here we have a worse problem because of translucency. Translucent things, of course, don't occlude the things behind them, so the overdraw gets even worse from distance. Alright? It doesn't have to do anything with memory, so it's just a side note. But that's why you sometimes should care not only about the memory itself. LOD0 is the best idea for memory, of course, but having more LODs cost you more memory, but save you render time. So let's generate some. Let's do build settings. Not build settings, reduction settings. Let's add an LOD. How do you do that? I don't remember. We have only LOD0. LOD settings. Number of logs, 3. Apply changes. Cool. And now, where are the loads? Load picker, LOD1. Screen size something, reduction settings, 50%. That's optimal. You shouldn't have loads that are less than 50% of the previous thing, because it's just a waste of memory. It doesn't save you that much when it comes to optimization, and adds more memory. So of course, a full LOD setup costs you have almost twice the original, because you have 100 plus 50 plus 25. However, look at this wireframe. So that would be LOD0, that is LOD1, and that is LOD2. Better, right? LOD auto. And now let's go to this view. Let's do not this, but optimization overdraw. Maybe further away. And as you can see, there's this switch. Now it's too dense, almost too dense, and then we move a little further back, and it switches to a next LOD, which is again okay. We move further away, and it switches again to a proper LOD. So now this color is more uniform than it was. We can try the same with lamp. Let's open this lamp. Or maybe no, because you understand the idea. LOD switches to the more optimal version with distance. However, when it comes to the cost, this mesh Radiator was 800 kilobytes. We refresh, and now is the heaviest mesh, 1078 kilobytes. meaning it grew in size by about 20%. But it's fine. It's really fine because it's not that much more and the rendering will be so much better. So you can imagine that if the scene doesn't have LODs and in total it takes some number of megabytes, then of course it will grow by about 20% if you add LODs, 20, 30%, something like that. Maybe up to 50 sometimes. Okay, so that's about the mesh. Now, there's one more thing about LODs. If you use baked lighting, you have to also bake it separately from LODs, of course, because the UV changes a little. So yeah. And now about more stats. Let's go to, it was an asset audit, I think. Wait a second, page. Yeah, asset audit was something else. But what I wanted to show, I think it was in stat then. Stat, no. It doesn't show us. God damn it. Okay, so play. And now stat. Scene memory. Oh, it's super small, super tiny small. And it's weird because it says just 5 megabytes for all things. Weird, I'd say. Okay. Start texture pool. That's weird. Allocated 0 megabytes. It wasn't that thing, but still, texture object pool is 0. What the hell? Start scene rendering, I think it's triangles and raw cones. Yeah, it's about timings. But why this thing is so low? And rendering stack 100 kilobytes? No way, just no way. Let's try another thing. And let's exit that. Standalone game. Bam. Don't see. Okay. Cool. So maybe now. Start. Texture. Nothing. Texture group. That's better. So take a look. Stats texture group. Used max is 517 for the word category. Normal maps 300 megabytes. So I'd say that for such a little scene, it's a lot. It's really a lot. But at least, as you can see, using these groups has this additional benefit of grouping stuff for the stats. So we can disable that. 517. Yeah, biology for textures memory, exactly. Stat engine trees, you say? Oh. Static mesh triangles, 21,000. That's interesting. Whoa, 200,000. Huh. It's not the memory, of course. But still, 260,000 triangles. Cool, that's nice. I didn't know that, thanks. And about the mesh, start Pause it. Memory static mesh. Total memory, 3 MB, 3.5. Okay, that's cool. So meshes are not our problem for sure. Okay, let's close it. Or maybe, wait a second, this texture group thing. Let's try R texture. How is it called? No, R. SG texture quality 1. Nothing. It should change something. I don't know. Anyway, let's find the next offenders. So, again, we play the game in the viewport. We go to tools, audit, statistics. Go to texture stats, sort by current memory size. And let's find the offenders. Diner tiles. Here. Okay, some tiles. 4K, max texture size. And use power of 2, always. So 248. Look, halving the resolution here, we reduce the resource size to a quarter. It's 21 megabytes, 5 megabytes, right? You get the idea, because this is x times y. Okay, so we reduce this. It's too normal. 4K, again, everything's 4K in this project. Max texture size, 148. Bam. We can do it even differently. We can go by project size, maximum texture, no, something like that. Texture size limit. Or wasn't. Or maybe it was in the platform. Tools, platforms, device profiles, Windows, click on these 3 dots. Texture, word normal map. Yeah, max LOD size, only 48. Bam. And word, same thing. Okay. Let's try if this works, because I'm not sure. Let's close it. Let's do. I have to re-import or no? Maybe I have to cook. Yeah, because if I open this RMA is 4K. If I re-import, I can re-import because I don't have the source. But probably I will have to cook this thing. Okay. So standalone game, I don't think it would be enough, but let's try. But I don't think so. Okay. Start texture group. No, 500 megabytes. Okay, so let's do a build. No build. Platform. Windows. Package. Project. And let's package it into RTV's pack. Okay, it will take some time. In the meantime, chat. Or I can use bulk. Okay, Under, you are a genius. Let's stop it. Cancel. That's perfect. Let's use bulk. So I select everything that's as standard texture. So textures, 2D texture. Select them. Right click, asset actions, bulk edit. Bulk edit, and this bulk edit is so recommended. It's so good. You select everything. You go either to property editor or this editor. Search for max size. Maximum texture size is multiple values. Let's set it to 248. Bam. it will be some time to do it, preparing textures, as you can see. Thanks Adept for reminding about the bulk edit. Okay. Save. Oh, it will take some time, of course. Oh, Sudoku says I could have clicked the pin to show the column here. Cool. As you can see, many textures were set to never stream, which means they will never use there. They will load in the final map. Okay, so if I use the pin, this column appears here. Cool, we reduced that. So let's again play inspected viewport. And let's do start texture group. And yeah, it's 350 megabytes instead of 500. So it definitely worked. Perfect. Oops. Come on. Yep, we reduced this by using the bulk thing. And now if I refresh this, you can see that only the glass has 21 megabytes. The rest is lower, 5 megabytes most. So that's how you do it. Can you only bulk edit textures? No, you can bulk edit everything. Take a look. Select meshes, anything, any object. Now asset actions, bulk edit via property matrix. Here we go. Static mesh settings, nanite, not nanite, everything. Materials you can't edit. But material instances you can, I think. Cool. Okay, about the meshes. Let's go back to our radiator. It has some maximum LOD 0, but we can do LOD bias actually. What's that? No, we have streaming LOD bias. That, for example, for high quality, it should use. What does it mean? No ref. Let's try to use LOD bias. LOD bias 2. Will it change anything? Nothing. Okay. But when we go here and do R mesh, there is nothing. Default no ref not bias. I don't remember. Wait a second. There is no meshes here. Maybe here in the instance. No. Okay, so maybe I confused the engines between Red Engine and Unreal. Because I remembered about some LOD bias. Never mind then. Because what I wanted to discuss was to generate LODs, but then discard the LOD 0. Oh, here it is. Minimum load 0. Let's try minimum load 1 and save it. Does it work at all? I'm not sure. Maybe only when streaming. It works, look. Minimum load 0, but now I can say the minimum load will be 3. And here we go. It uses the optimized version. However, this is only for rendering, So I guess here you have the streaming LOD bias for preloading, yeah. So probably you have to use one here and here, because this is real time and can be overridden anytime. Okay. So here we go with meshes. And if you encounter something, you buy a pack of assets, there's something, this is so heavy, and you can't afford to open it in an external program, you just generate LODs. You can also go straight to percent triangles in LOD 0 and reduce that without generating lots. Take a look. We just optimize it. And you can always go back because the source is still there. So you can always try different numbers, go back. It looks fine. It doesn't look bad. Slightly more chunky, but it's fine. And this will be permanent. So if you build the game, there's no more LOD 0 original. So changing the minimum load, Bionic State asks, won't change the memory usage of the asset? So I guess that this minimum load won't change the memory usage, but no ref streaming load should. I think it should. I'm not sure though. But for sure, changing this percent triangles in LOD 0 already optimizes it like forever in the cook. But the source is still there in editors, you can always go back. Okay, so that's that. And now about the light map resolution thing. Go to, where is it? Light map density, bam. And here you can see that this is green, while this is red. And the pixels are so much denser. So this view represents the actual pixel grid of the light map. It's like super dense, super extremely dense. So you select the mesh. It's purple just for the visualization purposes of selection. You select the mesh, you go to the mesh itself, but also here if you prefer, and change it either for mesh or for component. So light map resolution 2K. What about 1K? It changed. Take a look. 2K, 1K, 512. But with 512, the pixels will be visible. They are big enough. But light maps are slightly blurry, so it shouldn't matter that much. You go to lit. Okay, it reset. I have to build the lighting to see it. So I can show you the straight comparison, but in general, let's build lighting. Yeah, build lighting. Katnowski says set number of triangles to 150% to release every master. That'd be good. That'd be good. Adev, do you remember when we are working on the VR project and the previous lead artist wanted to model everything in quads to future-proof the assets? Because he said that at some point we may just enable the subdivision for the next-gen port. Yeah, right. Okay, it's building the lighting. Let's give it a while. You don't remember it? Okay. I remember it till this day. Okay. Building lighting. About the blueprint, let's try doing something like that. Let's make a BP. Let's make an editor utility widget. UW texture finder. Okay. What? Twitch notification. Someone's live. Okay. And here, let's make a button on the top. Let's add some text to that button. Let's call it find texture. Where's the text? Oh. Print texture spec. Okay. Let's run this little tool. Right click run. Okay, we have it. It does nothing. So let's select this button, go to the bottom, on clicked plus. And by the way, if you want to know how to make such tools, give me a moment. Okay. So you go to techartade.com, you scroll down, and you find, where was it? Making editor tools. This. I can select the text. That one. So yeah, I recommend that thing. Here I described how to make anything that changes actors in the level. And in the second thing, making editor tools part 2, I explained how to actually modify material instances, how to play with object properties. So this will be, I won't explain it here in detail because I already explained in the video, which I recommend. Okay, so on clicked of this button, let's do, there are subsystems, so search for subsystem, and here we have asset editor subsystem. Bam. We have that. Drag. Oh god. Let's restart. Black menus. Hit again. Okay, to rebake the lighting. As you can see, the resolution is really worse. It's also due to the noise. If you build the lighting in better quality, it won't be as bad. But still, not so beautiful. So going with 512 in this mesh was too low. We should go with light map 1024 probably. Let's keep it like that. Let's restart Unreal. Okay. Oh, one eye says that there are metadata in textures, so you can find about the alpha channel. Okay, let's go back to this texture finder. Oh, this lighting is really bad. Okay, this button on clicked. I added a subsystem. There's a lot of subsystems. You need them when you want to do something. For example, asset editor subsystem, but also editor actor subsystem if you want to modify something on the level. Okay, so we have asset editor subsystem. There's content subsystem too, or not? Yeah, content browser data subsystem. You drag from them. They're only available not in every blueprint, but in editor utility widget blueprint. In editor utilities. Drag from them. Get selected. Maybe it was here. What? Nah, wait a second. Get selected assets. editor utility library. What? Wait a second. Get editor. Wait a second. Maybe it's not needed in Blueprint. Okay. So you just go to editor, scripting. Okay. Asset tools, get asset tools. This. Okay, and now they should have get selected assets. Or don't they? Wait a second. Because I know we have this, I know. But I was sure you have to take it from something. So again, editor scripting. Asset. Selected. Save asset, load asset. Load asset. Okay. Then asset tools. Containers. Whatever. So it's just there. In development editor get selected assets. Okay. And now, if you get selected assets, then for array, like a for each. God damn it! Why is it so bad? Like I just want for each. Really, nothing fancy. I no longer have a for each in my Unreal. Like, really? Is it possible? I deleted it, or do I have branch? That is that. Okay, so maybe flow control, sequence, branch. I don't have a for loop? What the? Add that you also had it? Maybe I close it and open again. Conflict for each. What the hell? I have to close and restart? It's too much. It's just too much. You had to copy it from another project? What the heck? Let's open that. Let's go to here. Click. Do F4. No way. It's just no way. I don't have a for loop in this project. It really happened. I can't believe that stuff. Oh, Bionic State loves my background. My background is an artwork, but I don't remember the artist's name right now, but I can find it. It's beautiful. Okay. I don't have a for loop. Okay, I'm sorry. I don't have a for loop. I don't know what to do, so I just get 0. Yeah, exactly. Chat. Paste this node in the chat. Thank you. Let's try. Okay, let's try. Ctrl V. Wait for it. Could not be pasted into that graph. Sadokun, can you post it on Discord? Post it in stream feedback or something, or live stream chat. Thanks. Okay, so I'm getting detection number, asset number 0. Cast it. Wait, what type is it? Object reference. So I do load asset. Asset path. No. Load. Oh, a second. Okay. Paste it into notepad. Nope. Okay. Okay, I got selected assets. I'm getting this. But what type is it? Load assets editor subsystem load. Did I lose all standard macros like while? Yes, seems so. Piotnashkin, it seems so. Thanks, Sadokun. Thank you. Perfect. Thanks a lot. For sure. Okay. It works. Thanks a ton. Verify Unreal in the Epic Launcher. Okay. Thanks, Sadokun. It's called pair programming. Okay. But I have object reference, so I don't get how to convert it into an asset. So I have to cast to what? The texture to the. I don't think it's enough. Maybe there was another subsystem. An editor subsystem. Use import. Editor utility subsystem. No. Get subsystem. Oh, it should be this. What does it offer us? Editor scripting, asset tools, create asset, export asset, rename asset, open editor for assets. Okay, what does it take? Array of objects. Cool. Let's try if it works. Let's just try if it works. I'll just open for make, open for this. Let's try. Open editor for assets. Compile. And let's run it. This texture finder. Okay. Select a texture and click this. Yay! It works. So it finds the asset. It opens them. Okay, so back to BP. This thing. Here. So this for sure works. So now get selected assets, and for every one of them, Load asset, get path, get system path, get path name for loaded asset. But is it loaded? I don't think so. Load package, there should be something like that. Find package referencers. No. There isn't any load. There should be load. Load asset. Yes. But it wants a path. I don't have a path. So maybe that's already a loaded asset. Let's try. Let's try to cast it to texture 2D. And then print its name. Or get size. Okay, let's print the size. Print size. And if it fails, let's print fail. Print string fail. Okay, let's try it. Run. Select the texture. Output mark. Print. It printed 248. Perfect. So we have a way to print this. Let's edit this utility designer. And let's add some texts. So this will be text name. This will be text size X. And this will be text alpha. Okay. And here, let's type none. None and none. And rename this thing so we know what it is. So this will be called text name. This will be called text size X. And this will be called text alpha. Okay. Now we go to our graph. We drag from them. There should be somewhere. Where are they? Wait a second. Where are they? We should make them a variable. Go back to designer. All this text is variable. Yes. Save them. Now they are here. So let's go. Text name. Okay. So we cast to this texture on click and we do multiple things. If the text cast was correct, then do a sequence. Okay. And add a texture 2D. First, get name. Full path. The display name. Okay, and let's divide it by a dot because dot in Unreal means a package. So split string by dot. Ignore case, and let's only take the left part. So we take set text name and set text. What? No. Set what? Content? Oh, come on. Set text. Any binding? Okay, I don't care about binding. Left, yes. Let's try. Okay, we select the texture. Oh, empty. Okay, let's just set this. Okay, it's fine. So I was mistaken. It's not a package name. It's just a name. So we get it like this. Okay, so it set a text name. Now the second thing, we take this text size X. Good. We set text to texture to D, get size X as a text. And the third thing we do, we take this texture alpha, set text. We take this and get alpha. Get compress without alpha, cool. I think get compression. Get compression settings. We get compression settings. And we do a switch. What? Yeah, and here we have different compression settings type. Wait, it won't tell us about the alpha. Damn it. So it doesn't matter. No, so not compression settings. Get. Who said something about metadata before? I think it was one I. Or was it one I? Remind me. Texture have metadata. Do they get metadata? Okay, but what type? So we have this. How to find this metadata? They are there. Has alpha channel. False. Has alpha channel. Okay. So metadata tag values. Fine. And let's search for has alpha channel. So it's the same thing as on the hover, but without spaces. Okay. Let's try to find it. And if it succeeds, so let's print if it succeeded or not. So text alpha for now will be just the boolean if it found such tag or not. Okay, let's run it. Select the texture. There's no such tag, so this doesn't work, unfortunately. Cast to texture, not to D. Okay. Cast to texture. It has to be 2D because normally it doesn't have texture size X. Bionic state has to go, but enjoy the stream and take a few pages of notes. Perfect. If you do something with it, let us know on Discord and see ya. Biodash says if I should ask type has alpha channel equals true here. You know what? Let's just print them. Let's just get keys. These are text. And just get 0, for example. 0 and print anything for now. None. So there are no keys, there are no meta tag values. That's unfortunate. Okay, so let's try what does it have. Texture? No. Rendering texture. Okay. Rendering texture. What? Anything about alpha? Get compressed without alpha. Let's try what? Okay, so set text alpha, set text this. Run it. It's running. Okay, BP is run. False. Okay. Do we have a texture with alpha? With actual alpha? Maybe some graphs. There's grass albedo. Yes. Alpha channel equals true. This one does. Let's print its stats. False. Okay. Aha, because it's compressed without alpha. Never mind. Has alpha channel true, so we have to get this metadata somehow. Okay, again. How to get the metadata? We have that. Get metadata tag. Has alpha channel. Let's try. Run it. Empty. Empty? Why? Oh, show metadata is grayed out. Maybe it's not metadata then. Has alpha channel. Let's search for it, you know. Oh, and by the way, a regular reminder, I have a Patreon. If you want to sponsor, then the middle thing and the last thing give you the replays of the streams. I post some replays to YouTube later, but yeah, this gives you all of them. Has alpha channel, but in Unreal. Is it metadata or is it what? Oh, there's a function, take a look. Has alpha channel. Just like that. So probably it's just not exposed to blueprint. It's in texture 2D, has alpha channel. Okay, and I think this one doesn't have such thing. Has alpha. Yeah, so you know what? It's not exposed to blueprint. Sorry. Is it in Python though? Let's try cmd python output log. So text equals Unreal World Object this thing, copy Or no, has alpha. Copy reference. So will be the P equals this. Text equals unreal node object P none. That's my text. Python wrapper. Text. Oh, come on. It's not Python. Sorry. Again. P equals this. Text equals this. Cannot non-P. Yeah. Text. It's here. Decal leakage. Okay. Class texture to D. Perfect. So text has alpha channel. No attribute. Okay, so I'm sorry, it's just not exposed. I think this one try Unreal texture to D text. Yeah, it's here. Has alpha channel. Sorry then. It's not exposed to Blueprint or Python. But in general, we were almost there. So this way you can do your own statistics window, basically analysis window. It's time to learn C++ to write tools. I don't know. Just use the bulk edit window. Okay, so that will be all for today. Thanks a lot for being here. I hope you learned something. And of course, go to Discord and let's have good discussions there as always.